and we are going to be looking at the mysterious microbes workshop. And before we go into any of the activities, I want to introduce you to what I think is the most amazing piece of equipment that you're going to find in your kit. It is our UV lamp. And we're going to be using the UV lamp for us to be able to find out about bugs on our hands, about how we can wash our hands properly, and then we're going to be looking at chemicals that we can use to kill those bugs. But before we do that, let's have a look at some of the things that we can do outside of the workshop with this UV scanner. Now, normally when I've got UV light, we can't see it. It's not within the spectrum for our eyes. But what we can do is we can use that light and it will energize chemicals which suck up the energy, so to speak, and it makes all the electrons move, and they move up and down within the atom, and as they move down they emit energy, and sometimes it's within the region that we can see as light. And so in the pack you've got to have a little sachet of glow in the dark powder. We're going to switch the lights off, so I'm going to go 1, 2, 3, and then the lights will go off. So 1, 2, 3. You can't really see me at the moment, but that's okay. I've got lots of little gadgets. See my t-shirt? I can put the UV light on my t-shirt. Woo! And I can activate the chemicals that's on my t-shirt. The powders that you get, look, I'm going to take the UV away, and they glow. Now they don't glow for a long period of time, but they do glow for minutes, maybe hours. That's another little experiment you can do. Now what I have on the table here are 2 bottles. One of them is some tonic water and one of them is water. And we have no idea what they are at the moment. The bottles are identical until I switch on the UV lights. And what we've got here is inside our tonic water, there's a chemical called quinine, which glows in the dark. Water does not glow in the dark. And I don't know, is my face looking a bit funny? So inside here, I've got beads which glow in the dark. I've got uranium glass. Uranium is a chemical which is energized, and it allows us to use it to get lots of kind of energy in experiments and watches and clocks, etc. So it's a high energy chemical. And what I want you to do is I want you to go into the supermarkets and buy the highlighter pens. And when you've got the highlighter pens, you're going to have to open them up, and inside you're going to have the color, and you're going to put the color into some water. Now this is a little bit messy, so I'm going to put some gloves on so that I don't end up with this fluorescent paint on my hands. But what we can do is we can extract that fluorescent color. It's non-toxic, it's safe, and when we put it in, look, can you see how it glows in the dark? In fact, lots of different foods glow in the dark. Try nachos, try bananas. Urine glows in the dark. So it's really important you can wash your hands after going to the toilet. Otherwise, we're going to be able to use our UV scanner to catch people out. Now, I'm going to put this water back into my bottle. And I'm going to use it in the next demonstration for me to be able to hopefully make some glow in the dark bubbles. Whee! There we go. So we have just made glow in the dark water. So we've just found out that our highlighter pens will glow in the dark. And you might find in the shops at the moment little toys. So here is a little bat, and in your kit you may find some beads, or you may find some insects or some stars. Again, they're all going to be able to glow in the dark, and you're going to be able to put them into your box and you're going to be able to hang your UV light and find out all the other crazy things that glow in the dark. Now, these are actually used by shopkeepers. I'm tidying my space here. And there are hidden secret codes in lots of things around us, and we can only see those codes whenever we've got UV light. So what we're going to do now is we're going to switch the lights off again, and I'm going to put the money into the money scanner. We'll take a little picture of it, and then you're going to be able to see those secret codes for yourself. Do you see the lines? Are there any other hidden codes in the money that you might have in your pockets? Are there any other things at home that have hidden codes? Ooh. We are now going to use our glow-in-the-dark powder to find out about hand washing. So I am going to need a volunteer. So pause your button, and once my volunteer is ready, you can start the video again, and then we can all do this experiment together. Okay. Welcome back. I'm hoping everybody is going to be doing this with me, not just one person, but if it is just one person, that's fine. And then after the show, hopefully you're all going to get an opportunity to do this. You've got this amazing, beautiful, it's really creamy hand cream. So you're going to put a little squirt into the pot, and then using your spoon, which I think you might find glows in the dark, much more exciting than my one, you're going to put a small amount of the glow bug powder into the pot. And we're going to stir it. So I'm going to stir that in. Lovely. And then I'm going to put a little bit on my hand. There we go. And I'm going to rub my hands together. And I'm going to go in between my fingers, the back of my hands, and on my thumbs. We're now going to have to switch the lights off to see what my hands look like. Now, when you do this, you're going to be using your glow-in-the-dark box, and your UV light will be hanging, pointing into the box. For us to be able to see it in the show, I've got my UV scanner here. I so hope I'm going to have germy fingers. So 3, 2, 1. Now it's the moment of truth. So our hands are going to go into the box with our UV scanner, and hopefully we're going to start to see some of those glow bugs. With a bigger one, you see my hands? Are they glowing? Are they glowing? Isn't that good? Let's switch the lights back on again. So welcome back. I'm in my lab, so it's not going to be possible for me to go to the sink. So when you're going to do this, you're now going to go to your sink. And you've now seen all of the bugs on your hand. Not all bugs are bad for us. The majority of them are good. But if we've got certain bugs that are going to give us a cold, the flu, any viruses, if we're going to get tummy bugs, then those are the bugs that we need to kill. And to kill them, we really just need soap. And I've got some really lovely soap here. Whoa! I love this soap. Ooh. And you have to, when you're washing your hands, you have to make sure you get lots and lots and lots of foam. The whole idea is the foam. And that foam will start to break down the outer layer of our bacteria and of our viruses. But to do that, we need time. More than 20 seconds. What can I sing? Oh, I know. When all the cows are sleeping and the sun has gone to bed, up jumps the scarecrow, and this is what he said. I'm a jingle jangle scarecrow with a flippy floppy hat. I can shake my hands like this, and I can shake my legs like that. You can come up with your own songs so long as it's more than 20 seconds. And this will mean then that the outer layer of the bugs gets broken down and all the insides get out and they die. Right, I'm going to wash my hands now, and hopefully when we put it back under the lights, I will have got rid of every single bug. And the reason for that is I was washing in the palms, I was going between my fingers, I was going at the back of my fingers, around the tops of my hands, trying to cover every area of my hand. Right, so let's switch this on, and I'm going to wash my hands. There we go. Ooh, I should have heated up the water. And what we're doing now is we're going to wash all of those bugs down the sink. If I had 1,000,000 bugs on my hand, using the soap and water, I will get rid of over 90% of them. That will mean there's about 100,000 left. So what we want to do is we want to get that number down really small, which is why you're going to start hearing about other sanitizers. Alcohol is the easiest one for us to put the message out there, but it's not a good one for us to use on our hands on a daily basis. So in your kits, you've got Activora, but there are lots of others in the shops, but it's having to understand all of these numbers. So we've got 99.999%. So when we go from 1,000,000 down to 100,000, we've got rid of 90. If I then use something else to kill them and get rid of another 90%, that means I've got 99. If I get another 90% killed, that gives me 99.9. And each time we reduce that number by another 90%, we add the nines. So I'm going to go from 1,000,000 to 100,000. From 100,000 to 10,000, that's 99. From 10,000 to 1,000, from 1,000 to 100, 100 to 10. That's what this one does. It breaks them down to 10. And that means if I do get some bugs going in my body, my own immune system will break them down. That's what their job is. And hopefully in the notes that you've got, that will be explained a little more. Right, I think it's time now to go on and do some more fun experiments. Welcome back. Now I've washed my hands and now it's the moment of truth. Did I manage to get all of those little bugs off my hands? So I'm going to switch the lights off again. And let's have a look. Can we see anything on my hands? Oh, I think I did a really good job. Give myself a big round of applause. Did you do the same? Did you do the same? I so hope so. Let's switch these lights. I'm only going to put one light on at the moment because I'm going to be switching the lights off again in a minute. Hello! And what we're going to do is we're going to do another little experiment, and I want to introduce you to a really cool chemical. It is really cool. It's minus 78 degrees. And what we're going to do is we're going to use our glow-in-the-dark water. Let's get some of this glow-in-the-dark water. There we go. Oh, that looks good. Let's get rid of that there. Oh! Let's get rid of that one there. So there's my glow-in-the-dark water. And it's fizzy. That fizz is a gas called carbon dioxide. And if I capture the carbon dioxide and in a container and I squeeze it and squeeze it and squeeze it, its volume gets less and less and less. And then it turns into a solid called dry ice. And the temperature is minus 78 degrees. We can't touch this with our hands because it would burn our hands. But oh, it's very freaky looking, isn't it? I love that stuff. And then what I thought I would do was see if I could use this to make some glow-in-the-dark boo bubbles, which could represent some bacteria. So what I've got here is 1 measure of fairy liquid. So that's going to go in there. And I'm going to use 7 measures of my glow-in-the-dark water. So that's 1. And the last liquid I'm going to put in is some glycerin. And glycerin is a type of sugar, and it's going to make my bubble mixture a little bit thicker, which means then that my bubbles will last longer. Because whenever we're using bubbles, gravity pulls the bubble film down to the ground. Now, let's see if we can use all of this science here to make some glow-in-the-dark boo bubbles, which are going to represent my bacteria. I'm going to take a seat for this one here. And what I've got here is a jar, and I've melted a hole in the side, and I've put a tube in through it, and at the end of that tube we have a funnel. Now if you've got two funnels, you could have a big funnel on the end there, and you'll have whatever we're going to see come out is going to go through that big tube and out through that smaller tube there as well. While I'm mixing this, I'm going to turn the lights down, and hopefully we will then start to see our glow in the dark water that we made earlier go into the pot. When I put in the dry ice, we're going to have a temperature difference of over 100 degrees. Whoa. So it's going to boil away. Let's put that on. And now we've got that gas coming out from that end there. And what I want to do then is I want to see if I can use this to make a bubble. Now at the moment, it's coming out really fast, so I think my bubble mixture will burst. We've got the carbon dioxide coming out there. It's not as fast as it was earlier. Oh, look. We've just made some nice glow in the dark. Ooh, bubbles. There's a little bubble. Woo! There's my bacteria. Squirt it with the Activora. Boom! The outer layer breaks down and all of the insides is released. Our bacteria reproduce every 20 minutes. We start off with 1, and then we get 2, and then 2 becomes 4, and then 4 becomes 8, and then 8 becomes 16, 16 becomes 32, and by the end of the day, can you work out how many bacteria we would have starting with just 1 at midnight? How many would we have? It's great mathematics. It's Science Week, and it's the Mysterious Microbes show. Good, bad, ugly. Our bacteria and viruses come in a whole range of formats. Viruses are generally ugly. They're going to always make us sick unless we use them in a vaccine. But bacteria and fungi, they sometimes are good. Here's my pizza. Look. So I've got my fungi there, my mushroom. That looks good. And oh look, I've got some salami. And we actually use bacteria to help us make salami. And cheeses and yogurts and all of those wonderful things, beers and wines. And for us to make the bread and the beers and the wines, we need a fungi called yeast. So in your kits, you would have 3 sachets of yeast. So in this experiment, you can put a sachet in each bottle, or like me, you can put it into a pot and just use a spoonful, so long as the measurements are all the same. So this is where I'm going to need a volunteer. So what we're going to do is we're going to pause the video in a minute, and my volunteer is going to have 3 bottles in front of them. They're going to need a balloon pump, or if they're good at blowing up the balloons themselves with their lungs, that's good too. So we've got 3 balloons in the pack as well. And you're going to have sugar. Now, I'm not going to investigate the amount of sugar that goes in. I'm going to keep the amount of sugar constant. We're making this a fair test. I'm going to experiment with temperature. So I'm going to have some cold water, I'm going to have warm water, and I'm going to have hot water. Because whenever we look at our foods, if we want to keep our foods for a long time, where do we put them? If I want to keep my pizza for a month, where does it go? Yeah, it goes in the freezer. And it makes all the bacteria go to sleep. And they don't wake up again until it gets warmer. Or we're going to cook it. And we don't cook it at warm temperatures, we cook it at high temperatures. And the reason for that, well, we're going to find out in a minute why we do that. So pause the video, and once my volunteer is ready, we can then start the video again. And we're back again. Fantastic. One of the things I suggested that we have is a funnel. If you don't have a funnel, that's fine. It just means that whenever we're pouring things in, have them over a tray so we don't make any messes. And what I want us to do first of all is in every bottle, we're going to put some yeast. I'm going to use a level teaspoonful, so you can do the same, or you can use a whole sachet. So I'm going to be doing this. And if my volunteer is a little bit slower than me, we can pause the video until they've caught up and then start the video again. So that's 1 spoonful of yeast in each of the bottles. And all of the bottles are the same size. You might want to use bigger bottles. If you do, you still have to make sure they're all the same size. Exactly, because it's going to be a fair test. Now, the balloons, they need to be stretched a little bit. And so what we're going to do is we're going to use the balloon pump and we're going to blow the balloons up twice, and then they're going to be ready to use. So, whee, that's 1. Woo, that's 2. And again, if my volunteer's not as fast as me, pause the video and start again when they're ready. Woo! And here's the last one. And here we go. Lots of physics here. This balloon material is stretchy. We've changed its shape. And when I release this, it's elastic and it's going to go back to its original shape. But oh, that air pushing on me. Right, so that's my balloons ready. Now we need the sugar. I'm going to put 2 sachets of sugar into each of my bottles. Volunteer. You're going to put 1 sachet of brown or white, depends which colors I gave you in your box, into your first one. Into your second one, you're going to put 2 sachets of sugar. And in the third one, you are going to put 3. There we go. I've also put in different ranges of sugar. So you might want to, after this session, do another experiment to look at the types of sugar. Does the yeast prefer white sugar, brown sugar, sweet and low, honey, maple syrup? All of those things there we can investigate. Now, I'm investigating temperature. And so in the kit, we're going to find a thermometer. Here's your thermometer. It's a digital thermometer. This is the temperature probe. So we just have to dip this into the liquids that we are experimenting with, or we can hold it in our hands or put it into blankets, whatever you want to use it for. But it's not just for temperature. It also lets us know the amount of water that's in the air. It's called humidity. So if we're going to be playing with bubbles, that's my other experiment, this lets us know the really good weather for us to make bubbles. We want a very high humidity, lots of water in the atmosphere, but we're going to use this just for temperature. Now, there's my 3 bottles. So what I need to do now is I need to measure 200 milliliters of water into my jugs. So I'm going to have 200 milliliters of hot water. I'm going to have 200 milliliters of cold water. And then I have to mix the hot and the cold together until I get a temperature between 40 and 50 degrees. So I'm going to pour in some hot water in here. We're nearly there. Fantastic. So I've now got a temperature of 45 degrees. And I'm going to measure that 200 milliliters into there. My hot, my warm, and my cold. Now I want to make sure that it keeps those temperatures throughout the experiment. So I'm going to put them into buckets. So that is going to be my hot water. I'm going to use the funnel. So my volunteer, you're doing this at the same time. You're pouring your water now into your bottle. There might be more than one volunteer. There might be 3 of you all helping together. So that's my first one. That's my hot. Here is my warm one. Again, using my funnel if I need to, or I can just pour it in carefully into the bottle. So that's nice and warm. And then the last one is going to be our cold water. Here it goes. And as we've done these experiments, we're making sure it's a fair test. We only change one of the variables in the experiment. Let's put the lids on and we're going to give them all a shake. Shake for 5 seconds. 5, it's me trying to speed up. Take the lids off again. And then we're going to put on our balloons. Yeast or fungi are living. They're part of our kingdom of life. So hot, I'm going to use the pink balloon. I'm going to put that over there. I'm going to use the orange balloon for the warm. And I'm going to use the yellow balloon for the cold. And I'm going to surround this, make a water bath with hot water. I'm going to surround my warm water there with some warm water. Making sure that it stays at 45 degrees. And then we're going to have cold water here. And so you might want to put some ice cubes in there. I've got some dry ice. Whoop! It's definitely going to be cold there. That's minus 78 degrees. That's just like putting it into a freezer. Our freezer's about minus 18. And then what we want to do now is we want to leave this experiment. So volunteer, thank you so much for helping me. And what we're going to do now, you can go back to watch, and I'm going to leave these here, and then we're going to see what happens over a period of time. Yeast is living, it needs food. But just like us, once we've eaten, we make wastes. And one of the waste gases we make is carbon dioxide. And yeast also makes carbon dioxide. And so hopefully we will start to see these balloons inflate. And that's going to allow me to find out which is the best temperature when I see the biggest balloon. Let's say after 10 minutes. And then set your clocks and look at it at 20 minutes and then 30 minutes. When you're doing yours, remember we're looking to see the amount of food. What is the optimum amount of food that your yeast is going to need? Is it going to be 1 spoonful of sugar, 2 spoonfuls of sugar, 3? Bakers need to know this. They need to make sure that when they're baking the bread, they've got the optimum amount of food for the amount of yeast that they put in. But they don't want to put too much in because then they're going to be wasting money. Right, that was good fun, wasn't it? So I'm going to say bye-bye for the moment and I'm going to move on to the next experiment. Welcome back. You may be wondering why I'm in the dark. Well, I'm going to need a little bit of darkness because we're going to be looking at the properties of alcohol. And the main reason for this is as our yeast is producing this carbon dioxide, This is our warm temperature, and the temperature is 48 degrees. We're finding it's making the carbon dioxide, but it also makes alcohol. And one of the weird things about alcohol is that alcohol actually is also used to kill yeasts and molds and viruses and bacteria. So whenever you have yeast working, it ends up producing a toxic chemical which will end up killing it. Now, first of all, I want us to look at some of the properties of this alcohol. So I have an alcohol hand sanitizer here, and I'm going to squirt some in here. Now, whenever we use this on a cell, so what I've got here is I've got an egg, and I put the egg into some vinegar, so I got rid of the whole shell, and it's all squishy. So if we imagine we had a bacteria, and this has been magnified thousands and thousands of times, it's also going to make waste material, which has to come through the cell wall, and it needs to feed, and it's going to go through the cell wall. So it's got that exchange, just like we have in our lungs, having the exchange of oxygen and carbon dioxide. This one here, I've had in some alcohol. So I'm going to put some of this alcohol in here. And what it's done is it's dehydrated it. And the shell is, it's all hard. And it's not going to allow any food to come into the cell, and it's not going to allow any of the toxic waste to get out. So that again is going to kill either the virus or the bacteria. So what we've got then is, if it's living, we're going to have all these processes that's going to produce gases and other toxins. Viruses are not living. They have to get into the cell of a host animal, and then they use all of the information in the cell, all of the food in there, for it to feed and live. And it will keep growing and growing and growing until that cell explodes, releasing lots more viruses throughout the body. Now, let's have a look at this alcohol. I'm going to put my safety glasses on here because the alcohol is very flammable, which means it burns really easily. And I've got a little wooden splint. So if we're going to burn anything, we need a fuel. So I've got wood here, I've got alcohol there. We need heat energy and some oxygen. Now the wood burns with a lovely bright yellow flame. And let me switch these lights off. That is the alcohol now burning. And if I just bring the wood down, it will start to burn there. Bring it back down again, and it starts to burn there. And that's going to keep on burning until all of the alcohol has been used up. We don't use 100% alcohol in the hand sanitizers because it does need the water there, at least 30% water, to slow down the evaporation process. Now what I'm doing here is I'm removing all of the alcohol that I had in that container. So I'm just going to switch the lights back on again for a minute. So I've removed all of that liquid there, and whenever we're in somebody's car and they're going into a petrol station and they're filling up, we can actually smell the fumes. So what I've got now in here is just the fumes of the alcohol. And here I've got Activora, and it does kill viruses and bacteria and molds, but it doesn't kill human cells or animal cells. They are made completely differently to those of bacteria and viruses. It is not flammable. I can put some into there. I can use my flame. It is not going to burn. Now what I've got in here is just the fumes of the alcohol, and I'm going to move that as far away from me as possible. So whether you're in a petrol station and you've got the fumes coming from your petrol, there's lots of signs that say no naked flames, no sparks, etc. Whenever we're using alcohol as a hand sanitizer, we have to appreciate it is highly flammable. So if you can, you're going to choose a hand sanitizer which has got 4 nines, 99.99, or 5 nines, 99.999, that's Activora, or 6 nines. And in the booklet, I will have explained very carefully what those mean in terms of the kill rate of the bacteria and the viruses. Boom! This is me checking in after 20 minutes. As you can see, there's no carbon dioxide in the cold or the hot. We've only had the yeast reproducing in the warm water. What results did you get with the food? Have you ever heard the nursery rhyme? Ring a roses, a pocket full of posies. We all fall down. Have you heard that? Well, that comes from the Middle Ages when the doctors were dressed like this. And the posies, well, they used to put them into the beak part of their helmet for the smell, because the sickness was so bad, the streets were so stinky, the doctors didn't want to have any of those horrible smells. Their eyes were protected with glass, and they had a hat. They were completely protected. And for the social distancing, they had a stick. They didn't want anybody to come near them. Doctors, 1320s. Doctor, 2020. Oh my goodness. Don't know how they see anything or do anything. When we did the yeast, we found out the yeast didn't grow if it was in cold temperatures, which is why we keep our food in the refrigerator or the freezer. We also found out that the yeast didn't grow when it was in the hot temperatures, and that's because the hot temperature actually kills the yeast off. The cold makes it go to sleep, the hot kills it. Now this pizza has been in my car for 2 days. I forgot about it and I thought, oh, I'm a bit hungry. I don't have a cooker, I'll eat it. What do you think would happen to my tummy if I ate a pizza that had not been in the refrigerator for 2 days? Shall we find out? Here's my stomach. Here's some bacteria. Are we ready for this? 3, 2, 1. Uh-oh. Ah! Oh my goodness! What's just happened there? the whole of my head just exploded. Oh my word! That was quite an experience. It didn't even get down into my stomach before I decided to be sick. Now, in the olden days, we would have had to start to clean this up. And once we've cleaned it up, we thought we might have washed our hands, but the germs would have stayed there and people would have touched their faces, touched surfaces. I'd have come along and touched the surface again, and then I would have touched something else. And that is how people get sick, by touching areas where the germs have been. I'm now going to have to clean up this mess. Bacteria reproduce simply and rapidly by doubling their contents and splitting in two. Just one bacterium dividing every 20 minutes could produce nearly 5,000 billion bacteria in one day. How long do you take to clean your teeth? I've got a little timer here. I clean my teeth, I'm sure it's about 3-4 minutes. I get in with the floss and I clean the back and the front of the teeth, and I'm making sure every surface of my teeth are clean. And this is what we should be doing with our hands, making sure that in between all of our fingers are cleaned and all of the little lumps and bumps are cleaned as well. To help us learn to clean our teeth, we've got these tablets called disclosing tablets. And one of you, hopefully, is going to be doing this experiment with me. So this is a time to stop the video, get the volunteer, and as soon as that volunteer is ready, we're going to start the video again. and welcome back. So what I want to do is we are going to open up this little plastic container that has the tablet in. And like me, the volunteer hopefully has not cleaned their teeth overnight. It's no good doing this experiment when you've got clean teeth because of the plaque is not going to show. Plaque is a name given to the bacteria that is on your teeth. This bacteria makes a slimy material that hardens, and it's so difficult to get off. The dentists have to use like a pickaxe to get it off. So I'm going to chew this tablet. So my volunteer, get ready. We're going to put it in our mouths together. 3, 2, 1. And chew. Squish it around. All the saliva. Now spit so they can see the color of it. Oh, that's disgusting. Now I'm going to get closer to the camera, and hopefully my volunteer is going to come around and walk past you all, but so you can see their teeth. Yeah? Are my teeth blue? Now, this is what the toothbrush is for. So we have to get the toothpaste on the toothbrush, we have to clean our teeth, and we can see where we miss just exactly the same thing. Just exactly the same way when you were washing your hands and we used the glow-in-the-dark technology to find out where we missed all of the germs on our hands. We use these disclosing tablets to find out where we've missed all of the bacteria on our teeth. Thank you, volunteer. So I've been away and I've cleaned my teeth, and it's now time to find out, have I missed any spots? Hello. Blue tongue. Oh, look, just inside there, I got a little bit. You're going to be able to do these experiments yourselves, and you can mark on your tooth diagram areas where you've missed, and then you can then use your brush and make sure those areas are nice and clean to stop tooth decay. And then also going to have to make sure we wash our hands to make sure we don't get sick. Now it's time for you to go away and do some experimenting yourself. And one of the things that you're going to be doing is the snot spatter experiment. You will be adding 200 milliliters of warm water to your pot, and then you have to give it a shake, 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 so that all of the glow-in-the-dark paint that was already in that bottle will be dissolved into the water. Now, one of the easiest ways to put out your paper is going to be lining paper, but any paper that you like can go on the floor. And I want you to organize it into 25 centimeter sections. And then you're going to do a sneeze. It can be 1 squirt for gentle sneeze, or it can be 3 or 4 squirts for bigger sneezes. And we want to see how far those sneezes will travel. Now, inside our bodies, we've got lungs. And then we've got this tube that comes up from our mouth. So when we breathe, some particles come out, and those particles have got mass. And so they're not going to keep on going. They're going to gradually be brought down due to gravity. And sometimes the wind is moving, so they can be traveling all around us. So what I want you to do is I want you to find out how far these coughs can travel. Now, this is a bit like our lungs. I can pull this back. Did you see the air move? Let me do it again. No, nothing moved. But I'm going to sit down here. I can fill this up with some smoke. And this time when I cough, do you see that? Oh. This is called an air zuka. and I've got my smoke machine here. And so what we're going to do then is we're going to find out if coughing or sneezing into our elbows or onto a tissue or into a mask, does that cut down the distance in which our coughs and sneezes travel? That's for you to find out. And the good thing is, inside here we've got glow-in-the-dark pigments, and you're then going to be able to bring yourselves into your box, switch on the light, and find out if you have been infected. There I am, sitting in the little black box. I've got my UV torch now. Let's bring it in and let's see if we have any spaces. Oh my goodness. Can you see all that spatter around my cheeks and my mouth and my eyes? That means if they end up going into my eyes or into my mouth or up my nose, then those germs will end up in my body and they could make me sick. Or lay yourselves down on the ground, switch the lights on, and move the UV light over. Have a fantastic science week. Really, really enjoy your Mysterious Microbes activity. I'm Scientific Sue. Bye!